Welcome to this tutorial on DynamoDB Tables. In this video, you'll learn how to create NoSQL tables in Amazon Web Services DynamoDB, understand their structure, and explore the key concepts needed to get started with this powerful serverless database service. DynamoDB is a fully managed NoSQL database service provided by Amazon Web Services. It's a serverless key value and document database that requires no server management. One of its standout features is high performance, delivering single-digit millisecond response times regardless of scale. Unlike traditional relational databases, DynamoDB offers a flexible schema, meaning items in your table can have different attributes. Additionally, it automatically scales to handle your workload demands, so you never have to worry about capacity planning. Let's understand the basic structure of a DynamoDB table. Every table must have a primary key, which uniquely identifies each item in the table. Items are the individual records stored in your table, similar to rows in a traditional SQL database. Each item consists of attributes, which are the data elements within items, comparable to columns in SQL databases. However, unlike SQL, not all items need to have the same attributes. DynamoDB supports two types of primary keys. The first is the partition key, also known as a simple primary key. It consists of a single attribute that uniquely identifies each item. Common examples include user ID, product ID, or order ID. The second type is the composite key, which combines a partition key and a sort key. This allows multiple items to share the same partition key, but they must have different sort keys. This is useful when you need to store multiple related items together. For example, you might use user ID as the partition key and timestamp as the sort key to store a user's activity history. Here's an example of creating a DynamoDB table using the AWS command line interface. The command starts with AWS DynamoDB create table. You specify the table name, which in this example is users. Next, you define attribute definitions, specifying the attribute name as user ID with an attribute type of S for string. The key schema defines user ID as the hash key, which is the partition key. Finally, the billing mode is set to pay per request, which means you'll be charged based on the actual requests made to the table. DynamoDB supports 6 primary data types. String, denoted as S, is used for text data. Number, denoted as N, stores numeric values including integers and decimals. Binary, denoted as B, is used for binary data like images or compressed files. Boolean, denoted as BOOL, stores true or false values. List, denoted as L, is an ordered collection of values. And map, denoted as M, allows you to store nested attributes, creating complex data structures within a single item. DynamoDB offers 2 capacity modes for billing and scaling. On-demand mode charges you per request, making it ideal for unpredictable or variable workloads. Scaling is automatic and instant, so you don't need to manage capacity. Provisioned mode requires you to specify and pay for read and write capacity units in advance. This mode is best for predictable and steady workloads where you can forecast traffic patterns. With provisioned mode, you can manually adjust capacity or enable auto-scaling to handle traffic variations. Secondary indexes allow you to query data using attributes other than the primary key. There are 2 types. Global Secondary Index, or GSI, uses a completely different partition key and sort key from the base table, allowing you to query data in entirely different ways. Local Secondary Index, or LSI, uses the same partition key as the base table, but a different sort key. The main purpose of secondary indexes is to enable efficient queries on non-primary key attributes without scanning the entire table. Let's review some best practices for creating DynamoDB tables. First, choose partition keys with high cardinality to ensure even data distribution across partitions, which improves performance. Second, start with on-demand billing for new applications, then switch to provisioned capacity once your workload becomes predictable to save costs. Third, Use composite keys when you need to model one-to-many relationships or query related items together. Finally, and most importantly, plan your access patterns before designing your table structure. DynamoDB is optimized for specific query patterns, so understanding how you'll access your data upfront is crucial for success.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.